Okay, so what we're doing is we are going to interpret the exponential function constant, okay? And it doesn't really have to do with the 1500. Again, it has everything to do with this, okay? So we have our function. It represents the change in a quantity over t hours. T hours, that's important. What does the constant 1.055 reveal about the rate of change of the quantity? Okay, so here's your first. Now, you guys are going to have drop-down menus. Because I printed this out, they give you the word bank. So 1.055 is bigger than 1, so we have growth. So the function is growing exponentially at a rate of what? Well, 1.055 minus 1 equals 0.055. They want the percent, so we got to move it 2 to the right. So it's 5.5%. Now here's your other word bank right here. Now, here's what you have to do. So we are in t hours. Okay, let's take a look at the exponent. All right, so our exponent is 60t. All right, so what we're going to do is we're going to take the reciprocal of 60, which is 1 over 60. Okay, so what that means is that's 1/60th of an hour. Okay, because that's what this is in, hours. Okay, well, 1/60th of an hour is a minute, right? There's 60 minutes in an hour, so 1/60th of an hour is a minute. So we come up here, and that's how it finishes. The function is growing exponentially at a rate of 5.5% every minute. Okay, we have another function. All right, so here's our constant. Okay, so again, 1.85, bigger than 1, so it's growth. So our function is growing again. What's the rate? Well, 1.85 minus 1 is 0.85. Move the decimal point. So we have a lot of growth, 85%. Okay, now take a look at the exponent. Okay, so by the way, t days. So we're in t days. Okay, so our exponent is t over 7, which, by the way, is the same as 1/7 t. Okay, so now we take the reciprocal. So the reciprocal of 1/7 is 7. Okay, now what we want to do with that is so our time frame is not a fraction of anything. It's 7 days. So the function is growing exponentially. Actually, 7 days. What's 7 days? 7 days is 1 week. So our function is growing exponentially at a rate of 85% every week. Okay. Okay. Here's our number. T weeks, that's important. So 0.97 is less than 1, so we have decay. So the function is decaying exponentially. Now, to figure out the rate, instead of subtracting 1, I do 1 minus 0.97, and I get 0.03. Move the decimal point. So that's 3%. Every what? Well, it's t weeks. So our exponent is 7t. Well, the reciprocal is 1/7. Okay, so that's 1/7 of a week. Well, how many days are in a week? 7. So that's 1/7 of a week is 1 day. So the function is decaying exponentially at a rate of 3% every day. All right. Last one. Here's our number. T days. Okay. So 0.9935 is still less than 1. It's close. Okay. But it's still decay. So the function is decaying. So 1 minus 0.9935. So that would be use your calculator. 1 minus 0.9935 would be 0.0065. Move your decimal point. So it's 0.65%. So it's 0.65%. That's not a lot. Every what? Well, it's t days. Okay. Our exponent is t over 7. So our reciprocal, again, this would be 1/7 t. So the reciprocal of 1/7 is 7. Well, that's 7 days. Well, 7 days is 1 week. So every week. Okay? So that's how you interpret the constant. Or the exponential constant, I should say, inside the parentheses.